All right, let's do one more optimization example. Example number 5. A paddock is to be formed by enclosing a rectangular fenced area in an open field. So I'm going to form some sort of paddock. It's going to be rectangular. The paddock must also be split in half by a fence in order to separate the cattle from the chicken. So I've got a fence in the middle, and I can't draw chicken, but let's just write chicken here and cows over here. All right, so let's keep going. Given that you only have 300 yards of fencing, what are the dimensions of the paddock that maximize its area? All right. Okay, so the first thing we need to do here is we need to get some variables in this problem. Now, you can use X and Y, you can use L and W, you can use all sorts of things. I'm going to go ahead and use X and Y. So I'm going to say that I'm going to put, now I have some choices here, excuse me. I could call this entire length X, that's one option. Or I could just call this part X and then this part X. All right. Either way you do it, you'll have some, you can get to the right answer, but you'll have to adjust things. I'm going to go ahead and do it this way. And then for Y, I'm going to call this length Y. Well, if this length is Y, I also know that this length is Y, and I also know that this length is Y. And I know that if this is X and this is X, because these are rectangular, this has to be X and this has to be X. All right, so now let's think about what the area of the whole paddock would be in terms of X and Y. Well, what is my total width? It's 2X. What's the length of my paddock? It's Y. So I've written a function of what I'm trying to maximize. I'm trying to maximize area. Okay? I've written a function in terms of area. It's the subject of the function, and it equals 2 times xy. All right, what else can I get from the question? Well, I've got 300 yards of fencing. So all of these distances, these two x's and these two x's and these y's, all have to add up to 300. So let's do that. I've got 1, 2, 3, 4 x's. I've got 1, 2, 3 y's. And that has to add up to 300. Now I've got two equations, each of which has x and y, so I can simplify this and eliminate one of those variables. So let's rewrite this and solve for y. Subtract 4x from each side. And now I have to divide each term by 3. Get 100 minus 4/3 x. Now I'm going to take this and I'm going to substitute it back in for y up here. So I get area equals 2x times 100 minus 4/3 x. Now, this is one where I could try to solve using algebraic methods, but let's do this one with Desmos. So I'm trying to maximize this function. And what that means is, if I graph this is going to be a parabola, right? Because if I distribute this through, I'm going to get an x squared term. And I'm trying to find the vertex of the parabola. I don't want to know the solutions here. I want to know the vertex. So I go over to Desmos, and I type in y equals 2x, and then 100 minus 4/3 x. Now, I don't have to simplify this. I don't have to, distribute through. I can go ahead and type it in with the parentheses in place. Now, I've already gone ahead and fixed the scale here, but you might need to play around with the scale to get a parabola that looks good like this. And what do I find? I find that my vertex is at 37.5 and then 3750. So the 37.5, that's my x value, right? So that's telling me the x value in the diagram over here. It's telling me that this length is 37.5. What is that 3750 telling me? Well, that 3750, remember, is this y value here. But what is y? What do we substitute? Y is area. So that's telling me what the area is of the paddock when x is equal to 37.5. So based on this, I have my answer. I know this needs to be 37.5. So this is 37.5. So this whole side is 75. And if this is 75 and this is 75, I can plug back into this equation right here to figure out what y is, right? I can do 4 times 37.5 plus 3y equals 300. And this is 150 plus 3y equals 300. And this gives me 3y equals 150, or y equals 50. So the answer here is that the dimensions of the entire paddock are 75 yards by 50 yards. But if this is all you gave me, I would say, not a complete answer. Remember, if I use my calculator here, I've got to at least draw some kind of sketch of the parabola, and I have to write calculator or Desmos here if I want full credit. So this is showing me the vertex. That's at 37.5, 3700. The roots down here, well, what were they? The roots were at 75 and 0. So I marked those quickly, and that's how I would get full credit for this problem. Go ahead and work on 5 through 8 in the homework.